All right, so we're going to talk about the very last lesson in Unit 4, and it is on the inverse trig functions. And we have discussed inverse trig functions before when we were looking for angles to solve triangles, where you'd use the inverse sine or the arc sine. We were looking for that angle that had a certain sign. So it's the same idea, except that we're thinking about it as a function. So for the arc sine or the inverse sine function, the domain, what you can put into it, has to be values between -1 and 1. And what you get out of it is an angle that's either in the first or the fourth quadrant that have that sine or cosine that you put in, or that sign that you put in. All right, so the range is important today. So those angles for the inverse sine or the arc sine are always going to be angles that are in either the first or the fourth quadrant. So the positive angles will be in the first quadrant and the negative angles will be in the fourth. All right, and then for the arc cosine or the inverse cosine, the domain is the same. What you put into it has to be numbers between -1 and 1. And then what you get out of it is going to be an angle either in the first or the second quadrant. So if you're doing the inverse cosine of a positive value, that's going to be an angle for the cosine. It's going to be an angle in the first quadrant. If you do the arc cosine of a negative value, that's going to be a angle in the second quadrant. All right. And then for the tangent, the arc tangent, we can put any value, any real number in for the arc tangent. But what you get out is going to be an angle either in the first or the fourth quadrant. So the arc tangent of a positive will give you an angle in the first quadrant, and then the arc tangent of a negative value will give you an angle in the fourth quadrant. And then I have the graphs of the functions, the inverse trig functions there for you. We are not going to do any graphs, so that's good. So anyway, that's what the graphs look like. We are doing just the bare minimum with this. There's so much more we could do if we had more time. So for example 1, we're going to find the exact value using a right triangle sketch. All right, and what we're given is going to look weird, but we can figure it out. So we have the sine of the arc cosine of 2/3. Now, when you look at that, you're like, what in the world does that mean? So this arc cosine of 2/3 is an angle. So what comes out of arc cosine is an angle. So basically, if that value, that 2/3, is a positive value for arc cosine, actually for all of them, if it's positive, that's going to be quadrant 1. So we'll draw a triangle in quadrant 1. Should feel familiar. We're going to put theta at the origin. So we're looking for a theta that has a cosine of 2/3. So that means that the adjacent is 2 and the hypotenuse is 3. All right, and we do need to know that third side. And since that third side is a leg and not a hypotenuse, we're going to subtract. So b squared is going to be the hypotenuse squared minus the other leg squared. So 9 minus 4 is 5. So that side is the square root of 5. All right, so what we're looking for now is the sine of theta. So theta is represented by that arc cosine. So once we get that triangle drawn, we can find the sine of theta by doing the opposite over the hypotenuse. Okay. I know that's different. And if you've never seen that before, then it's kind of overwhelming. But it's possible you might see something like that on the ACT. It's very likely you'll see something like that on the challenge exam. All right, for B, we have the cosine of the inverse tangent of -2. Now, for the inverse tangent, what we get out of it always has to be an angle in quadrant 1 or 4. Now, if this value here is a negative, that's going to be quadrant 4. So we'll go ahead and draw a triangle in quadrant 4. We'll call this theta. Now, what I know about this triangle is that the tangent is -2. So that would mean when I do the opposite over the hypotenuse, I get 2. It's negative because it's in quadrant 4. All right, now what I want from this triangle is the cosine of theta. So I do need the hypotenuse. So because I'm looking for the hypotenuse, I'm going to add with the Pythagorean theorem. And apparently the square root of 5 is my favorite number right now. So the cosine of theta, the cosine in quadrant 4 is positive, so that's good. So we're going to do the adjacent over the hypotenuse, whoops, or the square root of 5 over 5 in reduced form. Okay, and we're going to do some more examples on the back. For C, we have the cosecant of the inverse cosine of negative square root of 3 over 2. All right, so let's go to the inverse cosine. When we are taking something out of the arc cosine or the inverse cosine, it's an angle either in quadrant 1 or 2. Now, since this is a negative, that means it's going to be quadrant 2. There's my theta. Oops. All right. Now the cosine is the square root of 3 over 2. So the adjacent is the square root of 3. The hypotenuse is 2. This is a special triangle. We've actually used this a whole lot. So I hope you guys already know that this is a 30-60 triangle. So that means that opposite side is 1. Now the answer to this problem is going to be the cosecant of theta. So that's going to be the reciprocal of sine. So that's going to be the hypotenuse over the opposite, or just 2. All right, now we're going to do some that are a little different, and they can feel overwhelming, but I have seen ones like this on the challenge exam. So we're going to do the cosine of the arc tangent of 2x. Now, when that is an expression, it's not a number, we don't know what quadrant it's in, so we don't have to draw it in a quadrant. We'll just draw a right triangle. All right, and then just to keep it consistent, I'm just going to go ahead and put theta there. Now, what I know is that the tangent of this angle is 2x. There's many ways we can represent 2x. The easiest way is just to have the opposite be 2x and the adjacent be 1. All right, and then to find the hypotenuse, it's going to be those two sides squared and added to each other. So c squared is 4x squared plus 1. So c is the square root of that. All right, so when I go to find the cosine of theta, I'm going to do the adjacent divided by the hypotenuse. Now, if this had been on the ACT, they probably would stop right there. But on the challenge exam, I'm pretty sure they would want you to simplify this, which means basically the same thing like we've always been doing, that square root just moves up to the top, and then the bottom is without the square root. Okay, we're going to do one more like that, so if you feel a little weird, it's okay. We're going to keep practicing. Let's look at E. We have the sine of the inverse cosine of x. All right, so since it's an expression and not just a value, we're just going to draw a right triangle. We don't have to worry about a quadrant. We'll put theta here. Now what I know is that the cosine of theta is x, which means that the adjacent should be x and the hypotenuse should be 1. Okay, and then we'll figure out that other leg. So since it is not in hypotenuse, we're going to subtract. So it's going to be hypotenuse squared minus the other leg squared. And then b should be the square root of that. Okay, so the answer to this question is going to be the sine of that theta, which is the opposite over the hypotenuse, or just the square root of 1 minus x squared. All right, so your assignment today is on page 327, 54 through 74 even.